It is March 1st, and it is the libhal bi-weekly meeting. So, a couple of highlights for this meeting. Quick mentions, the LPC PWM driver is ready and tested. And also, the MPU 6050 driver is ready and tested. So if you want to go and use those, you can totally do that. All right, first on the list, we're going to talk about migrating to Conan 2.0. Actually, I think I've swapped these items. It's actually going to be Conan build first, and then I'm going to talk about Conan 2.0. Last, we're going to be talking about our competition. So first off, let's talk about Conan build. Now, it only really works as nicely as this on Conan 2.0. Conan 1.57, which is the one we were using before, it requires a couple other things for this to work, but the new Conan does not, so which is great. So if you upgrade to 2.0, which will be happening basically actually pretty soon, the robotics team will not be using our one client. The robotics team won't be moving over, but so we need all the old libraries will work for them. But going forward into the future, we'll be using Conan 2.0 and whatever's the latest. Now, Conan build is a simple way to build projects without needing to follow these following commands. The current setup is make a directory, cd into that directory, do Conan install, then do cmake. A new item that a lot of people may not have had to deal with is source Conan build. This is actually the appropriate way to get all of the paths down correctly. And not doing so does have some issues where if you use it in certain environments on Windows, it may not be able to find where the compilers are. So you source the Conan build.sh. Once you have that all done, then you can finally make your stuff. Cool, great. My goodness, there's so many commands. So people make scripts for this, which makes sense. You know, why not make a script for this? I don't think it's the worst thing ever. It's not that bad, but it can be better. The Conan command is just it. That's it. Conan build is all you need. Let me show you a little live demo. All right, so I was already practicing it before, just making sure everything looks good and great. We're moving away from the Conan file txt like so to a Conan file Python file. You need that in order to run Conan build. I don't make the rules, I just follow them in this case. Although I do change the rules sometimes when I find that, they can be improved. So this is all you need. You have to specify your requirements, your layout, and your build. If you want to learn more about this, you can look at the Conan documentation, but this is pretty much all you really need. You can specify settings like operating system, compiler, and build type, although I think I should be able to remove this, actually. I don't think I need this at all. I'm going to remove it and move this live and see what happens. So we're going to do a build. So I'm just going to run the command, and I'm in the demos folder. I want to make that clear. So I'm in get libhal lpc in demos. I don't need to make a directory. All I need to do is run Conan build dot. Let's see what happens. Look at that go. It performed a Conan install. It generated a build folder. Did Conan install. It ran cmake. It did the toolchain stuff. It generated the cmake files. It ran the virtual environment for the build step, and then it built everything. All of that all in one command. No other instructions needed to build your project. Just Conan build dot, and you are done. If you go to the build directory, you will see a folder called release, and you'll see all of your good ELF files, binary files, hex files, disassembly files, other disassembly files, and so on and so forth for all your different projects. All of them there, and all of your additional CMake files that get generated are all here. So you have everything you need. Let's say you want to do a debug build. That was a release build. Well, you can do -s for changing the host settings, build type, build underscore type, is equal to debug, and you run it. What happened here? Oh, typo. There we go. And look at this. We have now a folder called debug. Before, you'd have to destroy your build folder and then make sure to set this flag and Conan install the next time you ran it, which was annoying. And even I hated it and I didn't have a good solution around this. But now you just simply go Conan build dash, build type equals debug and you're done. That's it. And then you have two folders. Debug with all your debug stuff and release with all the release stuff. Easy. Beautiful. Cover girl. So this works out pretty well. I'm really excited to be able to build everything like this because it removes so much extra effort on the libhal. How do you use it? Well, once you get through the very quick installation steps, you just do Conan build and you're done. And I think that's fantastic. So we are done with this list of 6 commands. Now you just do Conan build and you are finished. So that is Conan build. So happy to have it. You can only use it when you use Conan 2.0. Nothing is available for that yet except for libhal itself. Oh, I don't think I even merged that in yet. So don't try using this yet. I will put a post on the Discord when I'm telling everyone, hey, look at the new updated docs. They have Conan build in them. Use those. And I think I might need to fork the docs or make a new version of the docs so that we have the old instructions there too. But that's for another time. All right, migrating to the top. Migrating to Conan 2.0. Conan update no longer exists. This sucks. There are a lot of people discussing it on the C++ Slack currently. A lot of us want it back. I believe they made a issue so that we can actually thumbs up it on on GitHub. I may sick all of you guys on that issue so you guys can, inflate the numbers a bit. But mostly, it's really helpful and it makes the setup instructions really easy. Their recommendation, so I want to show you guys what it looks like normally. So let's go libhal.io. So the installing prerequisites, besides this step, which is changes depending on which operating system you're on, but it's still pretty simple. You go to Conan, you run this, and this actually can go away soon because it's no longer a thing. Then you run this, and actually you can remove this line here with 2.0 and then remove the insert. You don't need that either. And then you can just run this. And this would basically, this step up here, set up the default profile, which had like your computer architecture. It had what operating system you're running, all of that good stuff there. But usually what would happen is on latest Mac, everything's actually fine. This is all how it defaults to. On GCC, I believe it defaults to 9, which we don't support. We need 11 or above. Technically, we can try to be backwards compatible with 10, but we want the latest features, so 11's at least needed. And this is going to be incremented up as time goes up. But yeah, for Windows and Linux, we need to set GCC, which is going to be the default for Linux, but not the default for Windows. Lib standard C++, debug mode for default. I think it's a great default to use build type equal debug for most things. Then you can just set release when you need it. But you can also switch that whenever you need it. And then also, most importantly, the version is 11. And that's pretty much it. You just everything here can be copy and pasted. You want to know how I am so confident that this is super simple? There was a student on the robotics team who ran through all the instructions and was able to get things to work. And then I said, oh, you're having a little complication with this one thing. Oh, you want to just add this one field here. You want to add another argument, -G, Unix make files for it to work. If I show you the trying out here, you can see an example. Yeah, you need to do this. And he was like, what is a command line argument? And I'm like, wait, did someone install stuff for you? He said, no, I did it. I was like, but how did you get this far without knowing how command line works? I'm like, well, you just copy and paste everything. And I'm like, you do, don't you? You do, don't you? Got you. Okay, cool. So I helped him out. But like, and also told him you need to learn how command line works just in general. But it was nice to know that like the steps are so simple that pretty much anyone can get started with it. So that's a good +1 there. But it is kind of tarnished because we don't have this field here. I get why they removed it. It's worse practice in a way. The current solution, they said, is have a big directory full of all the different profiles that we may need, and then have people run a command to install them. The only problem is that I would have to have a profile for every single possible architecture that people may use our library for, and that sounds ridiculous. And I also don't think that we're their target audience. They're targeting people where they have designated specific systems they're going to be running on, and they have those specific profiles well defined. We don't really. So that's a thing. I'm still looking into how to make this better, how to simplify this. I may push them to bring this back. We'll see. I think there's a lot of people in that chat trying to push that to happen. So, yeah. But the cool thing, though, is that this, along other things, but not just this one, but a lot of things, actually made me have to try a little harder when it came to the CI. The CI completely broke. Everything that was going to use Conan 2.0, all the CI steps broke. But this actually allowed us to simplify things. One of them being the Conan build command, which made it possible for us to add in application building, which we now support. So going forward, 2.0 actually ends up simplifying things except for that one thing, although I was able to find a way around it. You just have to do -S for every single possible configuration you'd want to set. Um, Not the most fun, but it works really well for CI, not very well for humans interacting with it. And that's pretty much it when it comes to Conan 2.0. I think it's a much cleaner, better implementation. I'm really excited to use it. All right, our competition. So this here, I'm changing the definition for what we call competition. It is every single possible way that someone can program any platform or system that someone can use to program an embedded system. Why do I say that? Because people are going to choose between us and MicroPython. People are going to choose between us and OpenSimsys. People are going to choose between us and Linux, potentially. So they all need to be considered our competitors, in my opinion. I don't think this is going to branch us out too far. It just means that we need to understand the pros and cons of everyone else that people could pretty much use for embedded programming and understand where we sit, what niche we or what area we fit the best, and figure out if there are ways that we could improve our code base, our systems, our flow to basically match what they have or even surpass them. So let's go into a couple of these. I think people here probably have experienced some of these, but let's start up at the upper left because I actually heard about these recently. It's kind of messed up, but I did get some happiness from hearing that a lot of the students in robotics, when they were doing what's the word? They were doing hackathon. They basically tried to use MicroPython to make a very, I forget what the actual project was, but then they had to use an IMU and they wanted to also talk over Wi-Fi. The IMU library on its own, 700 kilobytes. To give you perspective, the SJ2 or the LPC 4078, the chip we use for the SJ2 board and the LPC micromod only has 512 kilobytes. You couldn't fit the IMU library on that chip at all, let alone the MicroPython code as well as also the Wi-Fi code. Just getting MicroPython on there wouldn't really fit. I believe MicroPython, it's been a while, requires at least 250 kilobytes of flash memory. I forget how much RAM it requires just off the bat. So they couldn't fit their stuff in there. They found some other libraries that were out there, but they said, yeah, it was rough to try to find a library that could fit onto their RP2040. They had a megabyte and they were pretty stretched, pretty thin, trying to get anything to work. CircuitPython doesn't really change the game too much. It might be slightly more efficient from what I might have heard, but I could be all wrong. I could be very wrong there. But that was cool. And all of them pretty much said, yeah, we wished libhal worked for the RP2040 and the Teensy. I feel like there's one more that I'm forgetting about that they wanted to have available. But basically, those two were huge. And I am more than happy to add support. Working on it takes time. And if you guys want to contribute, please and thank you. But that was something that I realized that we should include them as part of this because people will choose us compared to them. Oh, we use MicroPython because it's easier. Yeah, until you need to fit things. Let's look at some of the other ones. Platform I/O. Why would I even include that? Maybe it's a little bit of why. Maybe it's not the right approach here, but I think it makes sense. Python Platform I/O is a place where people can run multiple. You can pretty much use any and all frameworks and platforms. If we become part of the Platform IO ecosystem, then they're no longer competition. They're just another host for us to put our ecosystem into. But in a way, Platform IO also, from what I remember, it's been a while since I've used it. Actually, I'm going to look this up right now. How much time do we have? I've only used it 15 minutes. Let's do it. Platform IO. Cool. Custom white label programming stack DSP as a... Is this the right thing? I don't think this is... I'm going to just get rid of that. Just search this up. Okay, platformio.org. Got you. Oh, for VS Code. They stopped doing their web thing? Oh. Well. Oh look, they have like a whole suite for memory man, for actually debugging stuff like that. That's really cool. I like that. We'll probably get our stuff into them as well at some point. So, they're probably not like a full-on competitor right now, but that's something I hear people talk about is they think, well, Platform IO, why would you use you versus Platform IO? Because Platform IO's got all the other things in there. And I would say, well, we hope to be on there at some point. So you could keep using Platform IO if that works really well for you. And I like their pivot to VS Code extension because I think that's a great way going forward. And if we could leverage what they have and then just shove libhal into it, we're in a good spot. I remember Platform IO before being a place where it was also somewhat of a marketplace for different libraries where you could just download and install them, similar to how there's like the package manager for Arduino. And on that same note, Arduino has its own ecosystem of packages that you can install through their library search thing. And people will definitely ask, why would we use libhal versus Arduino? So they're a competitor. Modem IO is another little thing out there that is used for making drivers, but you have to, from what I've heard from other people who've used it, you have to buy into their whole system. It's like other vendor SDK, software development kits. You buy into all of that, or you have to figure out a way to generate their code and then bring it into your code base. Again, I really dislike options where you auto-generate stuff because honestly, auto-generated code makes doing a lot of development really difficult. And especially, I don't really like the idea of having people be stuck. That's why libhal uses Conan. Yeah, you're stuck with Conan for now until we support via VC package and other package managers. But the cool thing about Conan is that you get to choose your own build system, and I think that's important. And Rust Embedded HAL, we've talked about it before. They are the reason why libhal exists for C++. They're one of our inspirations. But people will ask, well, why would we use C++ with their lack of memory safety when we can use embedded HAL? I have my reasons for that, or I have my answers for that. Rust is still new. Rust is still developing. Rust embedded HAL, or Rust in general is pretty fat when you build it down and try to statically link it. So it's still trying to learn how to become lean. So that's another thing. We're lean already. So that's the thing. Johnny 5, JavaScript library, they're fat just like Python based systems are fat. Just takes you have to put an interpreter into your embedded system, so you have to pay that cost. But the big ones, the scary ones, actually Rust is on the scary side too, honestly. But the ones that I'm actually a lot of these guys are scary, but the ones that we really need to keep away, keep track of is Zephyr, RTOS, OpenSymsys. Those are basically the big two. Zephyr RTOS is blowing up. People love it. People are running to it. I will never enjoy using it. Reason why is because they use the device tree method of organizing things like Linux does. And not gonna lie, I cannot stand it. I don't know very many engineers who can. It's nice because if you're good at Linux or if you've done a lot of Linux development, you can just take that knowledge over, which I think is great. I think there's benefit to that. But the device tree whole system is very gross and difficult to work with, in my opinion, hard to debug. And it ends up it ends up being a bit of a pain, and I think it's probably, in my opinion, I bet it's probably not as efficient as not having it, and having to pass these pointer objects all around. So we have competitive with Zephyr, RTOS, and actually let's look them up real quick, so you can see their webpage. Like, look at this. Oh, that's not it. That is not correct. Is it Zephyr R? Am I spelling it wrong? Oh my goodness. Okay, it's just called Zephyr. I think it used to be called Zephyr RTOS or Zephyr OS. Okay, cool. Yeah, events under Embedded Open Source Summit 2023. They're having summits. They're part of the Embedded Linux conference. They have 450 boards supported, although, not going to lie, that's not the hardest thing to achieve. We're working on that ourselves. Pull requests close, 120 repositories, that's huge. 1,468 contributors and a decent amount of commits. These are all huge things. And I think the difference between why people would choose Zephyr versus us is whether or not they are willing to buy into C, stay with C, because it's all C-based, buy into the device tree. That's going to be hard for a lot of people, but I think people will go that route. And then buy into the whole ecosystem, because you're kind of stuck there. With libhal, you can definitely just take all the different libraries piecemeal. You're not locked into the Zephyr project. And also, I will say that I'm kind of talking on my butt a little bit here. I've only seen some of the guides for this. I haven't really dug into it. I haven't really had experience using Zephyr, so I want to make that clear that I'm basing this off of what I observed from the outside. OpenSymsys, I've used Simsys a little bit in the background. This is another big one that's popping up. I got a little concerned because, again, I believe there are also similar issues. You're baked into the ecosystem. You use what is available there. You can't just kind of use different libraries that exist outside of typical embedded land. But yeah, OpenSymsys is basically trying to open up not just. I think they use they're mostly built for ARM, but I think they're trying to expand to RISC-V, and that's an area that I want us to basically take control over as well. So OpenSymsys is going to be something that we gotta look out for. And to finish up here, we have the different vendor SDKs. LPC Expresso, which I don't think anyone actually probably a lot of people use it, but normal lock-in, you have to work with their IDE. ESP IDF and STCube. Obviously, all of these vendor SDKs don't really fit what we're fighting against because we are a hardware abstraction layer and we give you more capability. But the thing is, people will say, well, why would I use you when I can just use the cube and just get things to work with cube, right? So we have to keep that in mind that those things are sticky. When you're kind of locked into these, you get kind of stuck. So we have to help them unstuck themselves from these vendor-specific SDKs. And then finally, Linux. Linux is another option. People can just say, oh, well, why would I use your thing when I can just run it on Linux, get a Linux like Pico. Oh man, got the name. It's Pico something. But basically, you could use it's going to irritate me. But basically, you can use the Pico version of Linux. I've got the name of the distro, and probably get it to run on systems that maybe have no more than maybe a couple megabytes of flash, and go from there. So they are all competitors to us, and I think we need to keep them all in mind. One thing to say to everyone who's watching and listening, and who's currently in the Discord, if you have time to investigate any of these, please investigate these so that you can give me feedback and maybe even write a little bit of a report about what benefits you get from using them, and then also what issues you have with them, and also what could we learn from them bringing that to libhal, because I think we can learn a lot of lessons from what others have done, our competitors have done, and learn how we can make us even better and more great. And that's pretty much it for today's video meeting.